Okay, to factor a quadratic trinomial, you can do it by trial and error. It's a trinomial of the form ax squared plus bx plus c. There's your trinomial. To factor it, well, an example of a trinomial you can factor is over here, x squared plus 3x minus 28. Now that comes up in relation to another problem, but we can just look at this. How do you factor this? Negative 28 could be 1 times negative 28 or negative 1 times 28, or 2 times 14, 2 times negative 14, negative 2 times 14, and so forth. So you could try factoring this as, for example, x minus 2 times x plus 14, or x plus 14 times x minus 2. It doesn't work out. You don't get the right number in front of x until you get to x plus 7 times x minus 4. And it's x plus 7, not x squared plus 7, times x minus 4. This works out. 7 times negative 4 gives you the negative 28. 7 times x and negative 4 times x gives you your 3 times x. So there's the familiar factoring of a trinomial. To tell whether a trinomial is factorable or not, so here's your trinomial, some number times x squared, the number times x, plus some constant number. You can go back to the fact that this is going to equal 0 only if either x plus 7 is 0 or x minus 4 is 0. That means the zeros of this expression would either be negative 7, which makes this 0, or 4, which makes this 0. So we can say, okay, here's our trinomial. It's equal to 0 if and only if the quadratic formula gives us a 0. The quadratic formula has a discriminant. If that discriminant is positive, then you do have a 0. You can express the value of x that makes this 0 in terms, well, it's just negative b plus or minus the square root of quantity b squared minus 4ac, all divided by 2a. The key is that square root of b squared minus 4ac. If b squared minus 4ac is positive, then the square root exists as a real number, and you have two real number solutions. If the square root is of a negative, you don't have real numbered solutions. You have complex imaginary solutions. So the discriminant, in order for this thing to factor, for the trinomial to factor, has to be non-negative. Okay? The square root isn't an integer or a rational number. You can't factor it over the integers or rationals. Even more. The discriminant is this. So we say if the square root of the discriminant isn't an integer or a rational number, you can't factor the thing over the integers or the rationals. Now you can factor it over the irrationals. Quadratic formula gives you the factors. And we'll see that in the last video. Okay, now let's just do an example. X minus 4 times x plus 7 times x plus 3. Now here's a polynomial that's already factored. We multiply it out and we get to this. Now, if you didn't know any of this and just had this, how would you find the factoring? Well, you would look at the number 84. Notice that 84 is the product of these three constant numbers here in your factoring. This means, even if you don't know this, you know that if these are integer factors, if you have integer factors, you have at least one factor with an integer. That integer has to be a factor of 84. 84 has to be a multiple of that integer. So the factors of 84 give you the possible linear factors of this polynomial. Okay, well, I'm just going to tell you, we know that x plus 3 is a factor because, of course, there it is. But more importantly, if you divide the polynomial by x plus 3, the x plus 3's divide out, you get this, and you get this. Okay? So that's obvious. Well, since this equals this product, if you do a long division of x plus 3 into this, you should get this. And we do. So we divide x plus 3 into this polynomial. Divide x into x cubed, we get x squared. Multiply x squared by x plus 3, we get x cubed plus 3x squared. We got to subtract this from this using the division algorithm. So we put little minus signs here to remind ourselves that we're subtracting. X cubed minus x cubed gives us 0. 6x squared minus the 3x squared gives us 3x squared. Then x plus 3, x goes into 3x squared 3x times. Multiply 3x by x plus 3, get 3x squared plus 9x. You've got to subtract this from this, so you put little minus signs here to remind yourself. And you do that, you get negative 28x. Then you divide x plus x into 28x, and you get negative 28x, you get negative 28. Multiply negative 28 by x plus 3, here's what you get. Now, you've got to subtract this from this, so you've got to change these signs to, little reminder signs to show you that you're in fact going to do plus 28x and plus 84 to subtract this thing, and it subtracts off, and you've got it. Okay, well, that simply demonstrates that if you can find a factor, and to find the factor, you got to just look at the numbers that divide into 84. Then you can do a long division and begin the factoring process. So we see that x plus 3 is a factor since there's no remainder, so that x cubed, so that this polynomial equals x plus 3 times this, which we already knew from down here. And then we can proceed to factor this term, and we have now 3 linear factors. Okay, so 3 linear factors. Okay, that's a process that we'll go ahead and use in some other examples.